raise of hands over here. Who's an Ekahau customer? Okay, good. Anybody without their hands up? Amin, did you get them? Did you get them? Okay.
Cameras everywhere.
And here, who uses the Sidekick? Okay, good. Okay, better question. Who uses the USB adapters and not the Sidekick? Okay, Amin, you're taking photos, right? You got them? Who uses the iPad for site surveying? Okay, okay, not many. Interesting. Okay. So the rest of you are carrying that that heavy laptop, running out of battery. Okay, no sales pitches, right? No sales pitches. Okay. Okay. So what we're going to do, we're going to give you a quick demo before we kick into the presentations of the new iPhone app. So we've brought the Ekahau mobile to the iPhone, and a lot of people have been asking us, does it really work? How does it work? How accurate it is? And so we just want to show you very quickly. We've got the floor plan of the Opera House. That's the Opera House, right? Yeah. By the way, how's the Wi-Fi? Anybody been testing the Wi-Fi? It's a Cisco setup, so. Yeah, yeah. So, so this is the mobile app running. Grant is just sharing his iPhone. So it's the same thing, right? Same concept is you upload the floor plan. And we've got 3 ways of surveying now. So if you look down here, we've got the stop and go. So still, you know, people and locations still require stop and go to analyze, and then you move around. We've got the continuous survey, and then we've got the new, autopilot. I got to get used to saying that. The new autopilot way of surveying. So what this is going to do, so the idea is, Ekahau's idea that what we're bringing to the market is we want more people bringing site surveying, if you will, to your sites, right? We want to make it easier. We want to, Wi-Fi is changing and becoming more critical. So we want people out there using the Sidekick, fixing their Wi-Fi more often than, you know, once a year, if that in some cases, right? Sometimes it's just pre-site survey, post-site survey, and then you'll never go back on site again. And what happens with the Wi-Fi? It just tanks, right, and goes down. So we want to bring this concept of continuously maintaining and validating your Wi-Fi on site. Okay, so by bringing mobile surveys, hopefully, you know, more hotels, more warehouses, more universities and colleges, they can keep maintaining and keep the performance of their Wi-Fi going. Okay, so the idea of the continuous, it was that you still needed, as you walked, to press on the floor plan as you walked while you're gathering the data with Sidekick, okay? And we made things easier because you didn't need to carry the bulky laptop while site surveying anymore. You just carried an iPad, and that allowed you to survey for, you know, up to 8 hours, and you didn't run out of battery. The issues that you get with surveying with a laptop, right? So the next thing that people were asking for is, hey, I don't like clicking on the screen, and, you know, can you make it a bit easier? We like doing GPS surveys because you just walk. So by using Apple iOS and the operating system, they actually have an AR kit, right? Augmented reality, 6 axes and the camera built into to the devices. So we're now utilizing that. And we can detect when you start walking, when you change direction, when you open a door, when you shake the phone up and down. So by utilizing that, what we want to show you is that we can now site survey without you having to click everywhere you're going. Okay, so let's see if we can get this working, Grant. So this is the room we're in. This is the stage. And Grant's just going to click and get it going. Okay, now he's walking, and you can see he's not clicking. He's not clicking. If he does click, it will be a dot, okay? But let's see how he goes, and let's see how accurate this is. So he's walking to the back of the room, walking around. Just introduce yourself while he's walking past. So So what do you guys think? Not bad, right? Not bad? Yeah? Will this make site serving a little bit easier? What do you reckon? No more clicking? Hopefully a little bit faster. Save you more time. Okay. Thank you, Grant. So there we go. Not bad, right? Okay, good. So that was just a quick show of our latest survey app. So I'm going to kick things off now. I think where's Mark Krischer? Where's Mark going up the back? So Mark's been he's been our man. So he was there at the first Wi-Fi Design Day last year when we brought this to Sydney. He was there in Singapore last week, and he's going to kick things off for us today as well. Oh yeah, here we go.
Okay, so thanks everyone for coming, especially thanks to the speakers. So really quickly, a lot of the speakers are actually here on their own dollar. We didn't pay them anything. Some of them flew in. They weren't sponsored by their companies that they work for. You know, Keith and Mark, they just did the Singapore leg, and now they're doing the Sydney leg. So if we didn't have those guys, we wouldn't have an event. If we didn't have the people that are coming today, we also wouldn't have an event. So big thanks to everyone for doing that. Today, Wi-Fi Design Day as a hashtag. If you're posting up on LinkedIn or Twitter, please do that. We've got some pretty sweet giveaways. We've got hats. I think we've got shirts. We've got backpacks. So, you know, post some things up. If you're creative, you know, we'll give out some bits and pieces throughout the day. Really quick look at the agenda. So it's going to be pretty rapid fire. We're already, we're still just on schedule. Yeah, it's going to be pretty rapid fire. We're going to be moving people through relatively quickly. So, yeah, anyway, we'll hand it over to Mark.
So before I get up, I'm actually going to introduce Jonathan Baroche from one of the local partners for Wi-Fi related solutions here based here in Sydney from Local Measure. So Jonathan.
Wi-Fi here at the Opera House, and so that was kind of a really unique experience for us. I'm the CEO of a company called Local Measure. We're an Australian tech company with offices globally, and we partner with Cisco. We're on their price list. What we try to think about is once you've designed the perfect Wi-Fi and once you've got happy customers, how do you extract like a new layer of value and something that kind of line of business buyers, line of business marketing operations would actually be interested in beyond just obviously great connectivity. So we have a couple of kind of solutions that think about how do you capture more data from the customers, how do you drive operational outcomes, and how do you kind of acquire and retain more customers for your business. So in the Opera House's case, they had a kind of few challenges. One is such a large portion of the people who come here are from overseas, but actually understanding who they are versus the local Sydney-siders is really, really tough. Because obviously if you're coming in a Chinese, with a Chinese tour, and actually seeing everything in English, you know, that's not the best experience. So I'll show you our solutions, which are all multilingual, helps you understand who the customers are, where they come from, and then understand across the precinct kind of what's working and what's not, so you can drive like a really magical experience. So if you logged on to the Sydney Opera House free Wi-Fi, you would have seen sort of a captive portal with like a really iconic harbour bridge. That's sort of our captive portal, and we run that on behalf of the Opera House, and we feed the data into their ticketing system. So if you opt in to marketing, they know who you are. Obviously, if you come back and you've got an hour to kill, they know that you've arrived an hour before your ballet. And so, you know, they can think about sending you communications, say, hey, why don't you go down to Opera Bar for a drink? Or why don't you kind of have a look at the seal, which lounges out the back of the house, and there's actually a bot that you can talk to the seal over Facebook Messenger. You guys should try it later. So let me show you quickly what our solution does. But obviously, you've probably all seen captive portals before, right? Some of the features that we've kind of developed with Cisco, which is pretty cool, is we obviously get the device default language out of the network, and so we automatically change everything that we do to about 25 languages. So if you're talking about a personalized customer experience, obviously language is the first way to start. We have obviously social media logins, and again, from a marketing team perspective, who are trying to acquire customers, who are trying to target customers more efficiently online. If a customer wants to log in using social because it's easier, typically about 30% will. It's a really valuable data asset for the business. And obviously we have the normal GDPR kind of privacy logins. Where it starts to get really cool, and kind of what Mark asked me to touch on, was how do you use wireless to change the physical experience? And what we've built with DNA Spaces and with Meraki is the ability to kind of serve a real-time pulse check on the customer. Like how's your experience been with us so far? And because we already know who you are, we obviously can fill in the room or where you are. We've got the location analytics, email, cell phone. And what that does is that routes an alert in real time to the front line. So here's the customer. They're on the wireless now. They're in Benelong Point, and they've just said the toilets are dirty. And so we route that to the janitor's service and can fix it. Because the reality is, like, the toilets are going to be dirty anyway, right? With or without the intelligence. But if we can get to it a couple of hours early and drive some operational efficiencies, that has a really big business outcome for the customer. Equally, just the identification of who the customer is and kind of asking them to opt in means you can have an ongoing relationship. So this is me, obviously signed on to the network, you know, where I am in the building, any of my social media posts that I've shared. So if, you know, this was me at the contact center event with Cisco a couple of weeks ago. So you start to get a really quick sense of who the customer is who's just complained. Obviously, you know, all customers are equal, but some are more equal than others. You know, if you know, this customer's a CEO of one of your biggest alliance partners and they're dissatisfied, and you know where they are in the building and you can kind of rectify it really fast. I mean, if you guys go to the operations team and say, hey, as a network administrator or you know, running a wireless network, if we could extract that kind of value and hand that to you on a plate, would you be interested? 9 times out of 10 they are, and suddenly then you can build an ROI or a business story for why you should do a wireless upgrade, or in fact why you should put in wireless to begin with, because sometimes these things are really hard, obviously, to get business buy-in. So we're all in the business of kind of real-time feedback, building out the customer profile. This is the guy who complained about the toilets. A lot of complaints about the toilets. The store was dirty, and you can see it kind of spins up a case, as you'd imagine any sort of case management, routes it to the closest person or into the contact center, and really kind of a clever way of using the network to find out what's going on in the local environment to drive a better and better experience. And then obviously, as you'd imagine, that can go into augment, you know, internal systems, Salesforce, CRMs. So you're learning more and more about the customer as they come to the precinct. And if you've got marketing automation, you can do some really smart things. You know, on the third time, send an offer. Like when they dwell in the gym of a hotel, you know, talk to them then about health-related events. So you're starting to build up segments and understanding the customers just based on their physical behavior. So acquisition of customers, understanding of the customer, and then obviously driving operational efficiency as an application that sits on top of wireless. So that's what we do from Local Measure. Thank you very much for your time. Mark, thanks for inviting me, and have a great day.
All right, good morning. Guys, you've got like until 3 before we get to go to the bar. Let's try that again. Good morning. All right, much better. My name is Mark Krischer. I'm Principal Wireless Architect for Cisco across Asia Pacific, Japan, and Greater China. Really want to give a thanks to Antony and Grant for giving me the opportunity. This morning I got to send a text to my mother and tell her I'm performing at the Opera House. Kind of cool. I want to talk about wireless security this morning, and also thanks to Antony and Grant for getting me to take a 90-minute talk and compress it to 30 minutes. I'm going to start with what is sometimes a contentious statement. A well-designed wireless network will be more secure than the wired network it is sitting on. How many people are surprised by that statement? And this is why I like presenting to a bunch of wireless guys, okay? Most wired networks do not use .1x port authentication, okay? That is why I can make that statement. Now, to be fair, you know, if you're not in the wireless business, haven't been for a while, there's a lot of misconceptions around wireless security, and to be fair, it's really our fault, right? Wired equivalent privacy. Who thought that trying to make wireless security equivalent to non-existent wired security would be a good idea, right? But the real important piece to recognize here is that wired and wireless are very different mediums. And so when we look at it from a threat profile, we need to think about it in very different ways. So if I look at the wireless attack surface, right? Wireless propagates beyond the physical boundaries of my area, right? So a wired network, the reason why people say, oh, I don't need any security on it, is because I've got physical access controls, right? Now, we know how silly an idea that is, but my point is, with wireless, we never had really the opportunity to even pretend that physical security would defend us, right? So if I look at the attack space, right, I've got wireless attacks can happen anywhere within the domain, the RF domain of my environment. All right, so what are things that I'm worried about? I'm worried about passive scanning attacks. Anyone can just sit and listen to my network. People can inject attacks into my network. And I'm worried about active jamming attacks as well. So really looking at layer 1, but also layer 2 that I can do a denial of service attack. The key point here is while I'm worried about attacks anywhere within my RF domain, the flip side is I'm not worried about remote wireless attacks, right? There's not going to be some hacker in, Siberia or, in Sydney in their parents' basement who are going to be attacking my wireless network. Now, from a threat perspective, we talk a lot about rogue APs and the risks that they can present to us. So worried about things like honeypot APs, evil twins, and also thinking about unsecured backdoor access, right? What happens if someone takes a rogue AP, puts it on my network because I don't have wired .1x port authentication, and now is using that for backdoor access. The clients can also be a source of vulnerability, right? So maybe they're doing ad hoc networking. Just by nature of how wireless works, they'll be leaking information that an attacker might use at a later date. That's what we call data seepage. And also, by virtue of the fact that these devices are mobile and are moving about, what are they exposed to when they're not within the confines of my enterprise network? Okay? Now, I'm going to start with some fundamentals, which I'm going to expect everybody in this room already knows, so I'm going to go through it really, really quickly. So we start with beacons and probes, right? And so the idea here is APs announce what SSIDs they have available, and the real reason I'm pointing this out is really to make the point that within that, they're going to explain what security context they're able to support. Now, clients are all looking for networks to join, and they're going to send probes, and in the response, they're again going to get that visibility of, hey, here's this network, here's what I support, my security capabilities. Now, the next piece, of course, is association. And here we're going to basically say, again, the client's making the decision, I want to join this SSID, and we get the association response. The AP can also send a disassociation request and get the response. What's interesting about that one is it's bidirectional. So my client can also send a disassociation request. Why would a client want to send a disassociation request? Any ideas? What would it be doing? Roaming, right? It's roaming. I'm moving to a new AP, so I've got to disassociate from the one that I'm connected to and reassociate to the new access point that I want to join. Okay? All fairly straightforward. Now, any wireless security discussion then really needs to start with WPA, or Wireless Protected Access. Now, it's important to recognize WPA is an interoperability standard from the Wi-Fi Alliance, which is separate to the IEEE, which creates the 802.11 standards, right? And so the real difference is the IEEE creates reams of paper, and the Wi-Fi Alliance creates an interoperability test bed. Any of you who have an engineering background, you know that if you take a spec, give it to 5 engineers, put those 5 engineers in a room, you will end up with about 6 or 7 different implementations, none of which talk to each other. That's what the Wi-Fi Alliance is all about. How do we ensure interoperability of the different products? So specific to security, they came up with WPA, Wireless Protected Access, which was based on the early draft standard of 802.11i, which is the official wireless security standard. Then when 11i was ratified, that was WPA2. The real difference between the two, just very quickly, is the encryption that we use. The older version uses TKIP, WPA2 uses AES. Why the difference? Because at the time that 11i was being developed, that was also around the time that NIST was formalizing the AES, the Advanced Encryption Standard, deciding which algorithm was actually going to be used for it. What that meant was we didn't have a lot of Wi-Fi chips that had AES in hardware. So we needed this transition phase where the older products that only supported RC4, which was used in WEP, and TKIP, they would still work, and then we would migrate to AES. The problem that we have now is there's still a bunch of people that are defaulting to TKIP, even though they don't need to, or worse, they're defaulting to WEP, which really at the end of the day, you might as well just put a sign on the door saying, door's locked, please don't come in. Now, the other piece of this is the authentication mechanism, right? And so this is how we're going to identify who is coming in to make the decision, am I letting you in or not? Two basic modes, right? I've got my personal, which would be for home, for pre-shared key, and enterprise, which is using .1x. Now, the big change that's happening is the Wi-Fi Alliance has finally, after over 10 years, upgraded WPA to version 3. And let's take a quick look at kind of what goes into that. First and most important point, and this I think is the best thing the Wi-Fi Alliance has ever done. They have linked WPA3 certification to Wi-Fi 6 certification. What that means is you cannot get Wi-Fi 6 certification unless you support WPA3. What that means is, by definition, every Wi-Fi 6 network will have an elevated level of security beyond what's come before it. Now, that does not mean that they are coupled, that you need Wi-Fi 6 to have WPA3. That will be a vendor-specific decision, what they do with their software updates. From a Cisco side, we support it on our Wave 2 products, but I just want to be clear, they're not linked, even though the Wi-Fi test bed has linked them. I'm not going to go in a huge amount of detail on everything that goes into it, but we will talk about a couple different elements. The first thing, though, that I do want to call out, the second best thing the Wi-Fi Alliance did, they have deprecated all those legacy, useless encryption algorithms like TKIP and WEP. It amazes me to this day that I still have customers say, I've got these legacy devices, they only support WEP. Do you support WEP? And my answer is, just go open. It actually no difference at all from a security perspective, and now with Wi-Fi 6, I don't even have to tell them that because now it's not even an option. We are going to go through some of these, so just a couple things to highlight. First one is it mandates 802.11 protected management frames, which I'll talk a bit later, and also crack testing. The one thing I do want to highlight with crack testing, people remember from a couple years ago, the crack attack? Everybody had to do a quick upgrade, right? The thing that I want to call out here, which is pretty cool, is this is a change in how the Wi-Fi Alliance does testing. I said that it was interoperability. That doesn't necessarily test whether or not you're doing something stupid. It just tests, can I talk to the other guy, right? With crack testing, we now realize I need to actually test that devices are doing the right thing. So that was actually a really change in their approach to what that interoperability test bed involves. The other thing that I'll call out is improvements to the encryption algorithms that are supported. What Suite B is really all about is we are on the verge of quantum computing. If you understand how encryption works, it's basically taking a very difficult to solve mathematical problem. Quantum computing will change the definition of what is difficult to solve. So that's what Suite B is looking to address. As we start moving into that, we wanted the foundation to have a good encryption base. There's also two standards which are not necessarily part of WPA3, but associated. They'll be their own certification as well, and I'll touch on these a little bit later as well. And Grant, just letting you know, your awesome timer there, I just realized is actually not counting down, so that's kind of useless. Thank you. Awesome. Yep. All right. All right, really quickly, authentication. So couple different elements here. First, we got the supplicant, right? So this is the device, the client that wants to get access to the network. The authenticator, despite the way the name sounds, it's actually the element that wants to authenticate the supplicant, but it's not the guy doing the actual authentication. That is my authentication server, or my AAA server. Now, I also need a store for my credentials, my sense of identity, and that'll be your credential server, typically Active Directory, some LDAP server. It could also be on the AAA server, but they don't need to be coupled, is really the point there. The reason why it's useful to understand the nomenclature is then to understand how the protocols are actually working. 802.1x is actually between the supplicant and the authenticator. And what it's there for really is to tunnel the extensible authentication protocol between the supplicant and the authentication server. The reason this is important is to recognize that my wireless infrastructure in the middle actually has nothing to do with the authentication sequence itself. Okay? Here's where you'll see why it starts to matter. So I get my association response like we had before. I'm going to exchange identity so we know like how to kick off my authentication sequence. And here's the key bit. I'm going to negotiate what EAP type, and now I'm going to authenticate against that AAA server. Okay? And the real implication here is that success, the authentication server needs to tell the authenticator, that is my controller or whatever type of environment, hey, this person, Mark Krischer is who he says he is. You can let him onto the network. So now we need to take a brief interlude to talk about EAP types. Got tunnel-based is typically what we use. You'll see Microsoft PEEP and EAP Fast, which is a Cisco. Both are IETF standards. And then you've got your inner method. So MSCHAP v2, that's the Microsoft Challenge Handshake Authentication Protocol, is typically what we use. Now, why do I need this inner tunnel? Well, basically because MSCHAP v2 is really, really old and is kind of broken. And so you can see it's using DES, which predates triple DES, which predates AES. The fact that I actually remember DES just means I'm old. What's the problem with this? So we're taking this string, but we're actually breaking it up into 3 segments, and we're going to do the hash on all of those. And the problem is I don't have enough bytes, so I have to pad out that last group over there. Plus, if I'm able to see this exchange, now it makes it really trivial for me to do an offline brute force attack. So that is why it's this tunneled method. I have to do this exchange in an encrypted tunnel so that you can't go and attack it and find out how to pretend to be me. Okay? In addition, there's some other ones, EAP-GTC. You can use certificates with EAP-TLS. Of course, if I'm using EAP-TLS, well, I don't need to do that as a tunnel method. I just do end-to-end EAP-TLS. All right? So that's my authentication. Now let's go back. So I've done my authentication. Now I need to set up my encryption. So I've successfully authenticated. As part of that exchange, both the supplicant and the authentication server create what we call a pairwise master key, which is basically a long random string of bits, which I'm going to use as my keying material. Remember, the authenticator wasn't involved. Therefore, I've got to pass that to the authenticator. Again, the controller type functionality, wherever that resides. And so now, really quickly, here's what we do. The authenticator is going to create a random string called the anonce, and it's going to send that to the supplicant, the station. And now the station has everything it needs to create the pairwise transient key, all right, made up of 5 elements. Pairwise master key, the anonce, and S-nonce that it's going to create now needs to send over, and the MAC of the AP and the station. When it sends that over, you can see that it adds a message integrity check, right? That's using the PTK it just created. So now the authenticator has everything it needs to generate the key, validates it created the right one by validating the MIC. It also needs to create a group transient key, which is used for multicast and broadcast. It's got to send the group key back to the supplicant. It's going to put a MIC on that as well. And now the supplicant can verify the MIC and say, yep, the authenticator has the right key, and sends back an ACK. This is the 4-way handshake. We're about 15 minutes in, and we finally have an encrypted link. Yes. All right. Now, that's great, except I'm mobile, so now I'm moving. Now I get to do it all over again. So what are the challenges with roaming? Well, I got two problems I got to solve. First off, my client needs to be scanning every single channel and find an AP that it wants to join. And then second, it's got to go through that four-way handshake again. So how do we speed things up? How do we solve this problem? This is what a number of protocols kind of come together to try and fix. So first problem is, how do we make clients smarter about what they're going to roam to? Well, we got two protocols. 802.11v, or BSS transition. This is basically allowing the AP to give some guidance to the clients, because those of you who have done a bunch of testing of Wi-Fi networks know that clients aren't always very smart about what they're going to do. So this is our way of making some casual suggestions of maybe what the right answer would be. A kind of lesser version of that then is 802.11k, which is neighbor lists. And here we're basically saying, hey, these are the APs that are in your area. These are the channels they're on. Don't go scanning all of 2, 4, and 5. Just go and check out these guys, see if they're a good place to start, and off you go. The next piece then is on the rekeying. And the idea here is I've already authenticated to the network, right? So the authenticator already has authenticated me as the supplicant. So what I need to do, rather than doing the whole four-way handshake again, I just need to prove to the authenticator that I'm still who I say I am, and that way we can shortcut that process and move on from there. One caveat. In trying to set this up and be flexible in what we wanted to do, the challenge that we faced was there is some potential backwards compatibility issues for some really old clients that are not 11R aware. And it's bad to the point that it can actually prevent those clients from getting onto the network. So the real message here is be sure to test what's going on in your environment. Where do we see these problems? It's typically really old wireless printers, and in some warehouse and distribution sites, sometimes we see some really old handheld devices. By the way, those old handheld devices typically only support WEP, so you should be changing them anyway. But that's just something to be aware of. Crack, I'm not going to go into the details, but what I do want to just call out, it is tied to 11R, and so that's where the issue was. Most of the issues were actually on the client side. From the AP vendor side, it was really, there was only one of the issues on our side. But just to be clear, this was an industry-wide event, and now we're addressing it in WPA3 in the test bed. The way that it was actually done is through a man-in-the-middle attack, and the idea was I could trick things to get it to replay the key, and doing that creates a known plaintext attack, just like we saw with the DES issue for MS-Chat v2, so it now allows me to attack. Now, the question is, why am I able to do a man-in-the-middle attack? How can I take this rogue and get people to associate with me instead of the legitimate? Part of the problem is there's no way for a client to know that when it receives a management frame, it's actually getting it from the AP it's talking to and not from some attack tool. This is because there's no integrity check, there's no validation of those frames. That's what 802.11w basically addresses. It allows us to put a signature onto those management frames, and so now the client and on the AP side as well, we can say, no, this is a spoof management frame, go away, I'm not listening to you. Because this is now part of WPA3, this really goes to the heart of why WPA3 is going to improve the level of wireless security across the board. We've basically immunized wireless networks from the vast majority of attacks that we see today. So this is really a big deal. I want to quickly go back to WPA personal and the pre-shared key. So this is what we typically see at home networks, but we also sometimes see it at Wi-Fi events where we put up a sign that has the pre-shared key. Not much of a secret if we're going to post it up on a sign, but there you go. Think about what we talked about with how I do the four-way handshake and this 5-tuple to generate that pairwise transient key. Of those 5 elements, how many of them are actually secret? Anyone? How many? 1. Everything else is sent in the clear. I send the 2 nonces. The MAC addresses are part of the layer 2 frame, so that's in the clear. This is the only secret. So if your pre-shared key is Ekahau Sid, or I love Sydney, right? It's very easy for me to do an offline dictionary attack and start to figure out what that might be, okay? So that is why everyone should go home and double check what their pre-shared key is on their home network, but also why we're looking to improve this in WPA. In WPA3. Just as an aside on this, if you are using pre-shared keys and maybe you're broadcasting on national television, your IT command center, maybe don't broadcast the pre-shared key on national television. Just, as principal wireless architect, this is kind of my guidance to you all. All right, so how are we fixing this in WPA3? This is simultaneous authentication of equals. Again, not going through the details here, the important thing is we are decoupling the strength of this algorithm from the pre-shared key that you select. So by all means, go nuts with Ekahau Sid on all your WPA3 personal networks. We'll be in much better shape. The other important thing to note is because of how this is working, we now can support 802.11w, which means that now your home networks are also going to be immunized to most wireless threats, same as the enterprise network. There is a transition mode, so if not all your devices at home have gotten upgraded, you can have that transition mode. My recommendation is going to be once all your devices have gone to WPA3, get rid of that transition mode. If you got friends who come over and they've got old WPA2 devices, get new friends. Okay? All right. Next up, anybody use Wi-Fi protected setup? Real simple. It's meant to let your grandmother get onto the Wi-Fi network. All right. Well, tell her not to use this. Let me show you how to take a perfectly good protocol and break it in a million pieces. All right, so I'm doing my identity response. Here I'm going to say WFA simple config. That's basically a key to say, hey, we're going to use a PIN to do my authentication. All right, so it's a 8-digit PIN, not too bad. That gives me a key space of 100 million, not great, but not too bad. Here's how we're going to make this absolutely useless. Instead of asking you to prove that you have the PIN, I'm going to get you to prove that you've got the first 4 digits of the PIN. And I really don't want to make it too hard for you, so every time you guess wrong, I'm going to let you know. So that's my NAC, my negative acknowledgement. So now for this first half, my key space is 10,000. Do it again for the second. So now my key space is not 100 million, but 10 to the 4 plus 10 to the 4, 20,000. And you know what? That's probably too hard as well. So that 8th digit is actually a checksum of the first 7 digits. So now we're at 10 to the 4 plus 10 to the 3, 11,000 iterations I need to do to break this. Awesome. So don't use this. How are we fixing it in WPA3? Wi-Fi Easy Connect. Now, this is not just for simple people at home to connect. This is actually more focused now on the IoT space where I don't have a user interface to get things onto the network. 3 phases. First one is bootstrapping, right? If I don't have a UI, how do I get some information to kick things off? So I can use a QR code, NFC, Bluetooth, whatever makes sense for the deployment. Now I can do my authentication because that public key allows me to set up my secure link. I can create the pairwise master key. I now get support for 11W. Everything's good and we're on our way, right? So that's the Wi-Fi certified Easy Connect. And the last one from the WPA3 that I wanted to talk about was Wi-Fi certified enhanced open, which if you look at why are we doing a pre-shared key here at this event, because if it was open, there'd be no encryption at all. So what OWE is all about is how can I have an open network where I have no idea who you are and yet still set up an encrypted link. So what we're going to do is we're going to use what's called a Diffie-Hellman exchange, which allows us to create a key between us without any previous knowledge of who each other is. And then we can go and do, again, our pairwise, the four-way handshake, and everything gets set up. The one thing I want to call out, and the downside of this, is Diffie-Hellman is susceptible to a man-in-the-middle attack. But we got to think about what the implications of that are. So this is, I'm at the Qantas lounge. Someone's gone and set up an attack tool to be a man-in-the-middle attack. So I connect to their rogue AP. That rogue AP talks to the Qantas network. We're still encrypted, so what this is just, the attacker has visibility to my traffic, but no one else in the environment does. Okay, so it's better than where we were, but it's still not great. Okay, so that's certified, enhanced, open. The last piece then is rogue APs themselves, right? So a rogue AP is any access point which is not part of my network. Now think of the implications of this, right? There's going to be a lot of rogue APs that you can see, but they're legitimate, right? Everybody is allowed to put up a wireless access point. That's how Wi-Fi works. There will be some that are actually malicious, and those are the ones that we're worried about. And the trick is figuring out which is which. So if I was to ask you guys to all go back to your networks and look on your wireless management tool, up in the upper right corner where it usually sits, how many alarms am I going to see up there? Am I going to see hundreds, thousands, tens of thousands maybe, right? People typically have a lot of alarms up there, particularly for rogues, because we never go and clean that up. We never go and say, hey, this is something I should worry about, this isn't. And what that means is we're basically not seeing any of the rogues, okay? The other piece that get asked a lot is, hey, I want to be able to tell if this rogue AP is on my wired network. Well, that's hard too. Why? Because when I hear that rogue AP, I'm hearing the wireless MAC address. But when I go and search the CAM tables of all your access switches, I'm seeing the wired MAC address. Now, for most products, there's a correlation between those two. You do, N plus 1, 2, 3, 4. But if I'm malicious and I'm an attacker, I'm going to get two completely random MAC addresses that have no relation. And so there's no way for me to correlate that. Remember, rogue clients, those are the clients connected to that rogue AP. They can also be a concern, right? Particularly if they're now enabling some backdoor access, because they can create ad hoc networks as well. All right? Last piece then is containment. So what is containment? Containment is basically a denial of service attack on a rogue AP, right? So think about that. We are actually attacking another network. You usually get away with it when the rogue AP is actually nefarious, right? If someone's doing something illegal, they're not going to come after you. But in the case of Marriott, they were attacking their clients' networks because then I could get people to join my Wi-Fi network and charge them money. And the FCC kind of hit them a bit hard for doing that. The other piece, though, is we just talked about 802.11w, which immunizes me from this. So what are the implications now of RF containment in a WPA3 world? The implications are I'm not going to be able to do RF containment. And so we need to start thinking about what my other options are, locating those physical APs so that you can send the boys around might be what we need to start looking at. All right? And that is wireless security in a nutshell. Thank you all very much.
Maybe I have to use the, oh, there we go. Okay. All right, so we talked before about the hashtag and the sponsored the event, and they've got some pretty cool giveaways. So Darko, I think you're around somewhere. Here he is. If you want to come up and maybe just explain what sort of giveaways you've got, maybe a little hint. Has anyone here done the ECSE, any of the ECSE courses? Oh, Keith, of course you have. So if anyone's done an ECSE and you've done it with Darko, rave reviews. And just ask anyone that's done an ECSE with Darko, they will tell you really, really good. Yep, there you go. So, so he's got some pretty cool stuff to talk about as part of a giveaway.
Thank you, Grant. Good morning, guys. How's everyone? Everyone got their coffee? Waiting for drinks, yeah? 3 o'clock? So what we are doing today is giving away 3 vouchers for ECSC troubleshooting class, which is the brand new class from Ekahau. $2,000 vouchers. I don't know exactly the mechanics of it. Grant, so do you want to explain it? How are we going to give them away? But we have a whole bunch of classes scheduled for 2020. So we're running design classes in Melbourne and Sydney. We have troubleshooting class, Melbourne, Sydney and Brisbane, and we're going to run an advanced class in Sydney later in May as well. So if you guys are interested in training, come and see me later, or wander around during breaks. So how are you going to give away those vouchers, Grant? I'll put you on the spot right now.
So we talked about the hashtag Wi-Fi Design Day. So at the end of today, if we just take a look at the agenda, and we are already over time, unfortunately, thanks Mark. But right at the event wrap up, we'll just go through and we'll cherry pick the most creative, the most likes, the most retweets, and we've got the vouchers, and then we've got some of the physical stuff. So that's how we're going to do it. So get involved. There is a media wall over there as well. That is what that is intended for. That's not just a big pull-up banner, so you can get photos and stuff like that. So yeah, but I think that's it, right?
Yeah, so we just look what we're looking for. We're looking for creativity, a bit of humor.
Yeah.
So keep tweeting, guys.
Pick one from Twitter, one from LinkedIn.
Sounds good.
Yep, that sounds good. And next up, we've got Aaron Scott, who, when he told me the idea of what he was going to talk about, we couldn't say no. It's a really good one, so I'm sort of looking forward to this. So Aaron Scott.
We've got a remote. Perfect. Don't need that. Cool. People can hear me, yeah? Cool. Oh, I don't care about a keyboard. All right. Good morning, everybody. When this came back up again for another year, I decided that there's no point talking about what everyone else is going to talk about, designing a standard network. I want to talk about something that's a little bit left to centre. So doing things like event Wi-Fi, so not like a stadium, that type of an event, but more of a pop-up, like a conference, trade shows, that type of thing. So things like this photo, because they all come with their own set of unique challenges. Everything's different everywhere you go. So I'm going to give away the tip straight up. I can walk off the stage now because that's pretty much all you got to do, right? Everything's prep. If you prepare everything still won't go smooth. We are going to quickly go through this. I know I'm going to try and make up some time, Grant, wherever he is. We're going to go through these, go through each of the steps so you get an idea of the things that are different from your standard install. So number one, the venue. Every venue is different. You're not going to be able to take a setup from one event and move it to a different venue because the physical spaces are different. You're not going to be able to take 2 different events at the same venue and have them be the same either. They're all different. So this is the International Convention Centre around the corner, just from these photos. One of the major things you want to do, you've got to get to that site. When you do a design, you can generally just get some floor plans, throw some APs up in Ekahau and get a fair idea of where you need to go, what your design's going to be, you know what your clients are going to be. Events, they're completely different. You need to know where everything is, where all the cabling points are, where all the IDFs are, how many points on the floor go back to certain IDFs, particularly if you're going to do the wired side as well. Internet speed. Who's been to an event and the Wi-Fi sucks? Who knows if the Wi-Fi sucks? Well, you people should, right? But generally a lot of it's internet speed. The internet pipe out of the building is horrible. So slow internet equals slow user experience equals blame the Wi-Fi. So knowing what that is lets you kind of plan. There's no point putting in a network that can pump out gigs of throughput when the internet pipe's 100 meg. Mounting locations. The not every place you want to put an AP, you're going to be able to put an AP. Going in and having a look and seeing what can I put, where can I put stuff, what can I clamp to, what can I, in events you're going to use cable ties and duct tape. You've got to do those types of things. You need to know, figure out as much of that in advance. The usual stuff, take measurements, obviously. And things like, I know it's obvious, but if you're going to do like breakout rooms in an event and they're going to be 2 rooms side by side, that wall in between is generally pretty dense. They're trying to do soundproofing, and so you want to make sure that, do I need 1 AP per 2 rooms, or do I need 2 APs, 1 each room type idea? So knowing all that standard sort of stuff. But the big thing here for the site visit is checking out the team that you're going to have to work with, the venue team. It's going to make, it's not necessarily going to make, but it's definitely going to break it if they're not very good. Now, this event that I'm going to talk mostly about was at the International Convention Centre around the corner. They do have a fantastic team. They are in the room. That wasn't just to make them be awesome. But thank you again, because you guys were fantastic. But you are going to have to need them. So if you know them, you get on well with the teams at the event, makes life a lot easier. Okay. Obviously, requirements. Most events, actually most designs, right? You need to figure out what the least capable, most important device is. For a general install, you know it's probably going to be laptops, that type of thing. Events, it tends to be more mobile devices, so you can have phones, tablets, some laptops. But there'll be other things, barcode scanners. So these badges don't have barcodes, but a lot of events do. They'll scan you as you come in the door. Those things are generally pretty not capable, right? So you need to think about that. But what happens when you have an event when the only device that you know that comes in is this thing? That is a robot that plays soccer. Not the unicorn, he doesn't ride the unicorn. But for this event, it was a RoboCup. It's an event for robots doing all sorts of things. One of the tasks is playing soccer. This is the only robot that we had reference material for. We can find out what the model is, look up the neck, and have a good idea. The problem really becomes when you start to turn up at the event and you see things that look like this. These are actual robots with the first 2 with the covers off. Zero idea what capabilities these are before you walk in the door and start deploying. So how do you plan for that? If you get a little bit closer, that's a little antenna. These 2 are from the same league. They're meant to be the same. They've got 2 completely different radio cards. So unknown drivers, unknown whatever they support, don't know what band, know nothing. I can look up this guy. He's got an FCC ID on it. But you don't know that until you're at the event. So trying to figure out how you plan things, even this one, lovely separation of the antennas there. And that wasn't it. Those little ones were about 15 centimetres high, but 6-foot robots. Those robots have, it's like I'm going to use a terrible word here, a router WAP. In there, that's up there, you can't really see from this far, but it's 2 little antennas sticking out. So that's what it uses to connect to the network. These robots all need low latency because they're talking amongst themselves to coordinate teamwork on the field. This guy was a particular interest. Let's not talk about antenna orientation, but this was 2 different radios. One was talking up to the network, and the other one was talking down to a laptop. I don't know what that laptop's doing. Yeah, pointing it to the laptop, yeah. That's wonderful. So you get things like during the event, this thing being connecting to the network okay, but because they're streaming telemetry off it on a different channel, it's killing fields that are next to it. So you don't see this. What about this one? Anyone see where the antenna is in that? The answer is going to be no, because it's in the middle of that metal box. So out of those, which one's the least capable, most important? Well, they're all the most important, and they all are the least capable. So the other issue of those is, so I've got no idea what's coming in, no idea of the capabilities. They're all important, and they all operate in different areas. But yet, a conference space is one big open room. So they're going to operate this as, because it's competitions, there's fields and arenas. Each of those arenas have different requirements. This is just a general list here. So things like keynotes, like up the top here, that's going to have a different application usage and device usage to your showroom floors. But in a lot of events, you've got to cater for both. So you're going to have keynote, maybe Twitter, Facebook, all that sort of stuff. A lot of photo uploads, different application usage. Go to breakout rooms, it's probably going to be more laptops, emails, note-taking type of stuff. Show floor, you're going to get a bit of everything. You're going to have people walking around doing that. It's going to be demonstrations. Trying to, again, you have no idea what that application mix is going to be. And transition areas, walkways, it's all about roaming and light use. But you really want to figure out, in the case of RoboCup, was everything hinged on latency. If a robot can't talk to another robot fast enough, the ball goes whizzing past and they lose. So the RF requirements of things like this, keynotes, breakout rooms, meals areas are all pretty stationary. You're not moving, you just come and sit down, you sit there. That's pretty straightforward. Walkways, nice and easy, it's roaming, it's walking down a hallway. So you're using power control and that sort of stuff to sort all that out. Showroom floors, again, you're going to have that mix. You're going to have people that walk, so you need to handle high roaming events, and then you're going to have people that are at a booth. And even though they're at the booth, they still move around. Like some of these booths at conferences are massive. And so they're going to be moving around. So what you don't want is some way during a demonstration for somebody's product, for that device to roam to another AP just because somebody's walked between it and the AP. So those are the types of things you need to think about. So just stationary is not necessarily standing still. What you want to think about is if it's a device is here, is there any chance that it might roam when it's there or if it's in this space? So for the robots, I don't want robots roaming from one AP to another on an adjacent field just because it got near the edge. That's not what I want it to do. And we'll talk about why for these robots in a sec. SSIDs. Mark's already talked about the security aspects of things. Generally for an event, it's going to be open or a pre-shared key. Doing .1x for an event generally doesn't fly. It's too much burden on the end user to get those things on. And for robots, well, they don't support .1x. Using SSIDs for segregation is something that you do in events. You don't have time to fiddle around with sort of profiling of devices and saying, okay, because it's this type of device, it goes to this VLAN. For events, you end up springing up different SSIDs. Now, what sort of an impact does that have? Generally in an event, not too much. So for RoboCup, there were about 46 SSIDs. They weren't all advertising out of everything, right? Everything was an SSID per field because that helps me control roaming. You're not going to roam to another AP if it's got a different SSID that it doesn't know. So on that field, single SSID, sometimes dual band, but some of these leagues had 6 fields. So it's a lot of SSIDs. But because there's only an SSID coming out of one AP, how is that any different from having one SSID come out of all of them as far as an overhead perspective? None. Security sides of the equation. Generally for an event, you don't want clients talking to each other. You want to be able to get out to the net. You don't want hackers on your network trying to hack into other people's devices. Showroom floor devices are a different beast. A lot of those things require 2 or more devices to talk to each other. If they're both wireless, then you're going to have different security profiles for both of those to enable that. From wireless to wired, who puts wireless users on the same VLAN as wired users? You shouldn't, should you? In events, a lot of times you have to, because you're bridging on showroom floors, you're bridging wired and wireless so they can do demonstrations. For the robots, everything on that field was in the same VLAN. So if you connect to the SSID for field 1, you got put into VLAN 1, say, and the wired devices on the side of that were monitoring the event were also in the same VLANs. So that way everything's there. So you do tend to do a bit of this. So you're kind of breaking the rules that you would try and avoid. Non-event Wi-Fi coordination. The venues generally have Wi-Fi. In our case, we weren't using it. We needed something more bespoke. The venue is going to fall into 3 categories. They're going to turn their Wi-Fi off. Yay. They're going to allow you to take channels out of their channel plan. That's pretty good. Particularly for RoboCup. We had the ICC providing the public Wi-Fi, and we were providing the event network. So we had our channel plan, we told them what the channels were, they ripped them out of the channel plan for their space. We had free reign on those channels then. They could still supply the public. Or they're going to tell you to go to hell, they're going to run their network anyway. And the other big thing there is BYO. You get stuff like this. This is not one of mine. It's on a tripod and stuff, so it kind of looks like an official setup, but no, it's just some home BYO thing. Generally, if for at RoboCup, these events, they're allowed to bring their own gear for certain leagues. This thing, dual 5 gig, 80 meg channels out of the box. And if you look at this one, I don't have a photo of their AP. That's a VR rig. They were streaming video from a robot in amongst all this wood here. So the AP, dual 80, streaming video from 2 different necks back to it into a VR headset. Every time they did that, robots at the other end of the venue would stop moving. Now, they weren't meant to. They weren't meant to have 80 meg channels, right? They were given to 20 meg channels. But that channel planning comes in negotiation between what people will bring in, what the requirements of the event are, and what the venue will let you use. So you end up at a list of, hopefully you've gone through this and you've managed to figure out everything. Now, the hopefully there for the devices is somewhat difficult. Again, for a lot of events, it's fine, it's going to be phones. You can look up Apple's documentation on how phones roam and what signal strengths. Samsung did the same sort of thing. That's all fine, but it's when you get these weird and wonderful things. Now, this is going to be the most obvious first line after this. Your design is based on your requirements. Now, the venue will have different abilities, so you may be looking for under seat if it's a keynote area. You may end up with tripod-based stuff, like the Wi-Fi stands in the top picture. Or you may end up custom printing brackets. Again, knowing the venue, knowing what you can mount on, sometimes you can get away with pre-made stuff, other times you need to custom make some stuff, so you end up with custom-made brackets. If you're in a show floor, you're probably going to end up rigging up sort of baskets out of cable ties inside stands and rigging things up inside it. It's literally whatever you can mount on. But you can come up with the world's best design, but if you can't get an Ethernet cable to that AP, do not do mesh. If you can't get an Ethernet cable to the AP, it's not going to go, right? So knowing those cabling restrictions, that's why that site visit right at the start is so important. Knowing where all the pits are, knowing if I put an AP in this spot, the event team can get me a cable there. Or the problem that a lot of these come up with, venue floor plan, or the event floor plan changes. RoboCup, they were changing up until a week before. So I did all this prep. Every week, different layout. RF design changes, channel plan changes, things keep moving around. And that'll happen. And even to the point where this small league in this picture is meant to be there when you get to the physical build. It could be a metre or 2 one way, which then covers up your floor pit. Go and redo your design. But again, it's something you're going to do on site. Controlling the roaming scenarios. Walkways, You want to make sure that you control the roaming down that. You know that if someone's going to make a phone call, it's going to roam successfully. If you don't want a device to move, bathe it in RF. Things don't want to move if the signal to noise ratio is high and the RSSI is high. They don't move. So if you've got a booth and you don't want something to start flip-flopping between radios, give it heaps of RF. Things like directional antennas give you things like this, where we've got a directional antenna covering that field. I know that those robots, as crappy as the radios are, I have absolutely soaked them in RF. They're not going to try and roam to something else. Now, hopefully at that point you've got all your requirements, you know where everything's going to be, you've got your designs all rock solid. Events do not have enough time. They are time poor. You get short bump in, so that period from when you can get on the floor and start deploying to the time the event goes live is generally very short. In some places where you've got lots of rooms all over the venue, you may not have access to every room at the same time. So you need to kind of plan that deployment of the APs for when you can get into it, which is where working with that team, again, gets you that knowledge. So they know what rooms you can get into and when. Work with them if they're helping you with the cabling side of things. All sync up. The number one rule here, and it's not written up here, is pre-stage as much as you can. Everybody loves zero-touch provisioning until you get to an event and you don't have time to fix whatever's gone wrong. Build everything, test everything, you're ready to go. Now, that would go, right, I've got my design, I've deployed it, I can sit down and have coffee and ignore everybody else. No, events don't work like that. Even if you've tuned it as part of the deployment, it doesn't matter. You're going to end up with bespoke changes. You're going to have extra APs. One of the leagues at RoboCup was a home-based robot, so doing menial tasks around the house. They decided they wanted to move one of their competitions from the venue that they were in to the kitchen. Kitchen wasn't on my floor plans. So having extra APs to be able to deal with those types of changes. Additional SSIDs, 100% number one, turns up every time. Someone's paying some money to get their name on the board. Ticker. They'll probably want their own SSID for their own space, right? So they want branding, or there's some additional security need. And to tell you the truth, it's quicker to spin up a new SSID in that one location than go and mess with security everywhere, changing VLANs, changing firewall rules, because that's going to lead to your regressions and other things will stop working. So it's generally extra APs, more SSIDs, and then you spend the rest of the event dealing with this stuff. That's a high gain Omni on the left, yes. Streaming video again. Dealing with that sort of stuff, they're not experts, they don't understand. For the first 2 hours on one of the days, I spent the entire time in that area logging into all their sort of Soho gear, changing all the channels and power and fixing what they should have done but have no idea what to do. The ones in the middle, people plug stuff in. That's not my switch. So spanning tree, massive problem. Also, your address space. I wasn't expecting every team in the venue to turn up with a 48-port switch and plug 48 things in. You run out of IPs. So dealing with that. The big one, though, was the best photo I had. These are all getting charged. This wasn't the problem. There was one section where they tripped the power for the entire section. How do we know they tripped the power? Wi-Fi doesn't work. Was the only complaint. Not that power's out, that the Wi-Fi doesn't work. The Wi-Fi was coming off floor switches, so they all went down. But that was their number one complaint. That was within 2 hours of me putting the APs up. 446 rogues, or suspected rogues, 58 actual rogues. So that's what you have to contend with. It is not a clean RF space. You have, most of those shouldn't be there. Most of them were people with their own kit testing on practice fields, not using the network that we built for them. You can kind of see it up there. It's not real clean. We spent more time than ever roaming the venue, tracking these down. And what makes it worse? People move. So you'd think, oh, I found an 80 meg one, and I'm going to go and find it. And then you go to where that signal strength is, and by the time you get there, it's gone. And you look, and it's down the other end of the venue. So you end up walking 30, 40 kilometres in a day, trying to track down rogues. Having a team to do this is much, much better. I guess the general gist of the whole talk was planning for events is number one. If you can figure out what the devices coming in are, awesome. Otherwise, you've got to do your best, and then that's where the second thing comes. I'm not sure I understand. Thanks, Siri. She's obviously not a Wi-Fi expert. You've got to learn to adapt. The ability to take all those changing requirements, changing floor plans, everything, and not freaking out and trying to murder somebody is a hard ask. The deployment is generally pretty easy. You can put APs out. Most events don't have 150, 200 APs. RoboCup was 24 APs. It's not that big. It's a big space. Whereas something like Aruba Atmosphere this year was 152 APs. Big difference. And then reacting, going and ripping out all those rogues. Even some of those rogues, you'd unplug them, come back 10 minutes later and they'd plug them back in. Those types of people were just destroying their own event. They don't get it. Now, I do want to leave you with one little video. Who thinks that Judgment Day, Terminator, that it's coming. Yeah, that still happens. But they're coming. They get back up. And they'll chase the ball. Yeah, they are coming. Just a long way away still. That's it. Thank you.
Thank you, Aaron. Okay, so next up we've got Dom, who's making his way up. I've just noticed there's a lot of people down the back area here, so it's not to everyone to look at them, but there's plenty of seats. There's 4 seats here, there's 3 seats here, there's multiple seats over here, so please come through and try and take a seat somewhere, which would be really good, just while we're in between. And if you haven't already, please jump on the event Wi-Fi. So the SSID is Wi-Fi Design Day. Password is Ekahau SID. So capital E, all the rest is lowercase, and then uppercase S Y D. So should be sharing my screen, but it's not. There we go. Okay.
You can hear me, but no one else can hear me. Oh, there we go. Okay, welcome to Sydney. I think we've got a bit of blue sky today anyway. I come from down the Sutherland Shire, so I've been sort of looking at black leaves and ash and all that sort of stuff. So it's been pretty fun, actually. Yeah, I'm going to talk today about more of a life cycle, Wi-Fi life cycle. I'm probably this guy here. All the other guys speaking are these guys. I'm sort of just come out of the knuckle dragging in terms of Wi-Fi. So it's sort of, what's my stake in the wireless game? Where do I come from? I've been involved in network testing, analysis, application performance monitoring probably for the last 18 years. I've worked with companies such as Spirent, who are test guys, of course the Fluke Networks, NetScout, NetAlley, whoever they sell to next sort of scenario. So I've spent probably 10 years working with Air Magnet and those sorts of tools until recently. Well, they were there. I mean, it's there's probably people that I've sold Air Magnet to and then converted them to Ekahau, so Antony's happy with that. But yeah, and we're now a gold partner with Ekahau. I'm sort of a co-founder of Plexnet back in 2012, so the views of mine are not necessarily endorsed by my company. But yeah, so we're across in that sort of area. So it's really about using the right equipment. We've all been in that situation. I don't know if anyone works on cars or have tools and things like that, but there's always the sixth nut out of six, the last one that gets rusted on and you can't get it and you strip it. And you can do things like chisel it off, or you can get a gas axe out, or you can get a grinder out and things like that. But you go down to Super Cheap and you buy one of these things and it makes the job a whole lot easier. So it's more about using the right tool. So there's a lot of screenshots that are going to come from different tools. It's more of a generic overview of things around that sort of using the right tool. And so, but people can use free tools. We also always get asked questions about, oh, I don't want to spend this much money on Ekahau. Isn't there something free I can use? Well, there is. I mean, there's a plethora of tools around here that you can use. There's some good ones and there's some cheap ones. I mean, your iPhone will do it. There's Android apps that will get you there, but they only get you so far. And AP vendors have design tools that you can use. And on the left-hand side, that's a vendor tool. So according to our office, we need probably 4 APs, but Ekahau tells me that I only need 2. So I mean, you spend the money for the tools and it actually makes a difference. And if they were so good, then most TENS vendors would go out of business. I mean, Ekahau wouldn't have the business it has today. So why do we care? Well, last year, Keith actually said this, and he actually did come up with saying, but it can actually suck as well. And, we all know that it will work, but you want to actually make it better. So where I'm coming from is a lot of things we see in our business is people don't really have a lifecycle support plan. So it's around planning, designing, verification, testing, and monitoring. So planning, and I said, get your requirements. I think Aaron alluded to that, get your requirements, make sure that you know what you're doing. To design the layout with the right APs. I mean, they've got generic AP in the Ekahau planning, but if you're going to use a Cisco AP, you design around Cisco. If you've got an Aruba AP, you design around Aruba. You don't sort of half and guess. I mean, you want to do it correctly. And then verify, site survey spectrum. So in other words, using the sidekick and things like that. Use ping, use iPerf. iPerf will give you some good information. Load capacity and roaming test. Now this is getting a little bit more into the expensive side of things, but I mean, there are ways to do these sorts of things, and I'm probably going to concentrate more on the test and monitor side, because all the other Wi-Fi guys are really, really good. They'll do more of the first bit. I'm going to look at more of that sort of load capacity, monitoring, and of course repeating. And this cycle is not a once round. If you're not doing this on a regular basis, if you're not planning, designing, verifying and going around and round and round, then you should be. And that doesn't necessarily always mean the testing phase, but it will certainly mean monitoring. Monitoring needs to be sort of 24/7 if you can do it. So basically mitigating crap Wi-Fi. So the areas of interest that we're going to sort of cover: wireless clients, roaming, APs, going into the network. So the network, the applications, the authentication, wireless LAN controllers, getting into the DNS, the services side of things, and of course going into the cloud, because everything's sort of moving hybrid, or some people are going to the cloud, some people are remediating back from the cloud, but cloud's always part of it. And then looking at the end user experience. So this is really the key to everything. You really want to understand the user from right down this side, trying to get all the way through his network into this sort of area. That's the sort of the key thing that we're trying to focus on. So the plan, design, verify. It's fairly simple. I mean, at the end of the day, it's not the only thing, but from this side of things, if there's people here that are using Ekahau, I saw Antony asked you, and you put your hands, and people raise their hands for who's got what. So really going into these tools is sort of pretty important for planning, designing, and verification. Of course, you've now got this little added autopilot, which is actually quite cool for anyone who's used it. But I'm going to park that side of things here. A lot of the other guys are talking about it. Aaron's already spoken about it. I'm sure Keith gets into it, and some of the other guys. So that's really where I'm going to stay over here. But then I'm going to get into what's the testing and monitoring side of things. So we know that people plan. In fact, there's not as many people that do that as you think. I mean, everyone here probably does it well because you're actually interested in Wi-Fi and you're actually Wi-Fi guys. But we see a lot of times where there's no planning, or we said, oh, listen, can you quickly run me a heat map for this AP design that the architect's done? And you go, oh, okay, so and they really want it to make sure that the architect thing doesn't suck. And generally it will, but there's no planning. And certainly when you get into the testing and monitoring side, this is sort of the approach we get. I mean, a lot of people here will actually, Aaron obviously was talking about stuff that's quite different, and I'm not really going to cover that. That's quite a different thing. But there's a lot of people who just don't want to know about it. I mean, they say, well, the vendors tested it, so it should be all be good. That's fine. We'll take their word for it. We'll just roll it out and it'll be good. And then if it doesn't work, it's all their fault, and I'll push it back to them. But a little bit of, take your head out of the sand sort of stuff. So the test side. Testing. Wireless low capacity. What to test? Why do you test it? I mean, AP authentication. WPA, WPA2, 3, 802.1. Looking at average and maximum client capacity. Do you actually know that? I mean, you don't know it if you're just doing a survey. And in this scenario, AP stability, interop. In this scenario, you've sort of got, okay, there is an access point here that we're testing. Okay, we can actually plug in, cable into that and test capacity on a known medium, don't have the air interface, and then what we can do is we can take those cables out, put it in situ, do it over the air, and then you can actually start to understand the differences between if I load up this AP or these APs, how many users, how many clients can I get, how much throughput can I get through it? We all look at what our specs say, it's all 1300 meg, we maybe get 860, realistically getting about 500, what do we get per client? So sort of understanding what the client needs as well. Of course, you've also can benchmark layer 2, layer 7 throughput, rate versus range. A little bit of that stuff's already done on some of the tools you use in the test and verification side. You can get rate versus range a little bit when you're doing heat mapping. You can get roaming performance. But when you start going into areas like this, now this is actually an example of a major airport in China. So what they did is they actually went into a big public area and they wanted to actually test how many users they could get in this environment. So using a whole lot of tools and traffic generators and antennas and a whole lot of stuff, they actually did capacity testing. So they went up under AP and they capacity tested. They said, yep, we can get so many users. And then what they did is they replicated these devices out in different areas, and they basically did the capacity testing, and then they roamed from one side to the other, and they actually emulated roaming. And they could emulate roaming at different speeds, so people could walk, people could run. So they emulated shoppers and things like that, and people were just walking around the place. And of course, you've then got Wi-Fi offload, which is AP hotspots to LTE, 5G, and things like that. So that little example is actually showing a gateway, but there's no reason why we couldn't step back one step and also test the access point scenario as well, or do it over the air. So this is actually wired in, but you can actually step back or step in, no matter which way you want to go. So testing with real traffic scenarios. It's always good. I mean, how do you test people? So it was like, you want to make sure that, can I emulate bandwidth correctly? Can I emulate channel selection? Can I do authentication correctly? Are there different passwords and things like that? You want to do fast roaming options and things like that. And of course, that's sort of indicative of what happened in the sort of China airport scenario. We've got multiple clients all going out, all generating, in this case, 64 AC clients or 256 N clients, all attaching to access points, all generating traffic, and being able to roam in between. So that's sort of like diagrammatically sort of how you go and look at these sort of stuff. Now, this can get expensive, but it's maybe one of the things that people need to look at. I mean, you can also do it through different tools. You can do multiple laptops. You can there's probably people here who have had to set up a whole lot of laptops just to do throughput tests, and then you sort of, it's sometimes an unknown entity when you start using operating systems and different NICs and that sort of stuff. So a good thing is, and these are sort of real world test results, as you can see, once you get up to about 300, 350 users, it's all pretty quick, and the last 50 tend to take a while. So understanding where your breakpoints are, understanding when things start to slow down, understanding things like, okay, I've got association, disassociations, I've got sessions coming up, sessions going down, things changing, things take time, things aren't linear, or things aren't as easy as what we probably model sometimes. So understanding real world environments, and of course then understanding net throughput, maybe per device throughput, and then breaking it down into some sort of historical view where I can actually see every single client, what signal strength he's got, how he's getting, what sort of response he's getting, what sort of throughput he's getting, and things like that. But what about iPerf? I mean, we all talk about supporting iPerf. I don't know if everybody uses it. Everybody should use it. It's a really good free tool to sort of get on board and use that to verify some things. I did a bit of testing at home. That's my home network. So I had a couple of tools there. So for anyone who doesn't know those screenshots, these are actually out of the air check. So you can see I've got a couple of results here. I've got my little wireless LAN signal out of my Wi-Fi signal out of my Mac. I've then got a air check giving me some signal strength, and I've then got here, that's a wireless LAN Pi, and that's actually a test accessory for the air check. And as you can see, although iPerf tells me my home network's pretty good, I've got a couple of APs and they're ubiquity, but they work. Get good throughput. I don't notice any difference between my wired and my wireless, which is the whole idea. But you can see 422 max, average of 288, 242, 238. I mean, it's a good guide, but it's not. I wouldn't be, putting my house on it. And then I get into using iPerf on a Mac. So same target. .218 is my wireless LAN Pi, but unfortunately I can't do it to the test accessory because it only works with the air check, which is a bit of a problem. So if anyone's looking at those sorts of things, I would actually go for the wireless LAN Pi above anything else because it's versatile. It works with any device. So again, I've sort of got that. And then I just did my iPhone. So you've got iPerf on your iPhone, you can do a quick iPhone. So between the three types of test tools, I've sort of correlated some sort of idea. I wouldn't ever use, in fact, when I first started doing this, my downstream ended up being 70 meg. And I went, oh crap, there's something wrong with my network. And I spent about 45 minutes trying to work out why I was only getting 70 meg. Until I thought, I'm just going to do another test. I'm going to use it with my laptop. And I got that result. And then I went back and did the air check again, and I got the result. I got same 70 meg. Then I went back and did this, and I got the better result. Then I went back to the air check, and then suddenly it came good, and I have no idea why. So it's always good, especially when using those sort of open source tools. Use a couple of different tools to sort of verify that what I've got off one device, I might get off another. I mean, they were talking about the most important, least cost sort of item. I mean, if that's the thing that you want to make sure that works well, then test it with that as well. And of course, that was a little test setup I had. I had them right next to that. It's the brand new one, which is a funky orange color, which is a really cool piece of kit, and the test accessory right next door to it. So when it goes wrong, I mean, we've seen things generally go well, but there are times when things go wrong. And this is actually a really good example. This was a network which was probably poorly designed. It probably could have been better. And there was some testing here that happened. As you can see, this was done using a piece of kit which is doing Wi-Fi 1564. So if you know Wi-Fi 1564, it's actually the next generation from RFC 2544. So it's doing throughput, latency, jitter. Whereas what 2544 just used to take one latency snapshot right in the middle of the test, so you really didn't know packet by packet. Y1564 does a regular latency snapshot, so you can or latency test, so you can actually see how your latency varies. Of course, the latency here is all over the shop because there's lost packets, and so it doesn't know when it arrives and things like that. So it tends to screw things up a little bit. But as you can see, looking at the upstream and downstream result, there's a massive amount of variation in this one, and it's really, really poor. So and this is just one client, by the way. This is not multiple clients. This is one client. So when that manifests itself into an environment where you've got multiple APs, multiple clients, that throughput result is actually going to have some pretty horrific things where, yes, we're running 40 meg channels, only 2 channels are used across the entire environment, so yes, co-channel interference. One spatial stream, why one spatial stream? You said, well, there was only one antenna hooked up, the other one wasn't plugged in. So suddenly, you've sort of got, the best client's got 20 meg, and when you've got to deliver throughput to a device over a certain period of time, you can't do it, this is going to fail. So it was good of the customer that was using this, had the foresight to go and test this and didn't believe what he said. When he was given the data, he's going, I don't believe that, I'm going to do this myself. Went out and started doing this. We actually lent him some tools to go and do it so he could do it. They've got some experience with these tools in previous lives. But going out and testing it for yourself and making sure that you're verifying what a vendor is doing. Which leads into sort of security as well. Testing manifests itself in lots of different areas. Mark was saying, a secure network, a well-designed secure network should be safer than a wires network. But how many people here know of very, very good, well-designed wireless networks? I mean, we'd all be out of a job if they were already good. So, they're not. There's variations from awful to really, really good. Can a hacker jump from your guest Wi-Fi to your corporate Wi-Fi or into an internal DMZ? Are there vulnerabilities in DHCP servers, DNS servers? Can they be exploited? Are switches, firewalls, routers appropriately patched? Is corporate Wi-Fi easy to get into? Is there poor authentication security? I've been into a lot of places where they're not using 802.1x. It's just WPA, and sometimes the passwords are quite easy. Anybody can jump in with Kali Linux or Pineapples and things like that, and it's part of a pen tester's general piece of kit. I mean, you can do a lot of this yourself, and some other tools you need to do things like maybe do you want to look at 24/7 situational awareness? I mean, there's tools available that will let you just stick probes in, like the internet, the corporate LAN, and the secure data center, and this guy, he's an agent, will try to attack that guy. The red, by the way, is the path we're not allowed to go. The green's the way you can go. So you want to try and go, can someone go from the internet and infiltrate into the corporate LAN? Can they then bounce from the corporate LAN into the data center, and then can they bounce from the data center back into the internet and exfiltrate data? So having an agent in each one of those, they're still bespoke. He still talks to him, and he still talks to him. They don't talk together, but by understanding the flow of how you do this sort of stuff, you can actually go, right, well, if I can get to here, and then I can get to here, and then I can get to here, then I can actually get right round through. And I've got a security hole. Of course, that's the path. And as you can see, it's a bit hard to see down there. Guest Wi-Fi, 5 scenarios into the internal DMZ. So it's relevant to guest Wi-Fi as well. Can I get from my guest Wi-Fi, okay, not necessarily my corporate LAN, I might be somewhere off the side here. Can I get from my guest Wi-Fi into my DMZ? Then if I'm in my DMZ, can I get into the LAN, and so on and so forth. So it's really good to understand your security posture as well. So, monitoring, 10 minutes. This is probably more of my background. I've come from a very large test and monitoring background. So I've done a lot of this on the wired network. And of course, there's a plethora of tools out there. You probably all have got something that does network application performance or application aware performance monitoring, those sorts of things. So it's really commonplace to see this sort of stuff. You've got SNMP, of course, you've got flow data, but Wi-Fi is a very different scenario. Of course, AP vendors on the Wi-Fi front have their in-house tools. Depending what they are, they can vary from being very good to being sort of poor. But at times, AP vendors don't play well with AP vendors. So if you've got a mixed wireless environment, you've got some Cisco, you've got some Aruba, or you've got some Ruckus, or whatever the case may be, do you have a program for each one of those? Do you have a product that looks at that and then a product that looks at that? I mean, you also want to try and keep in effect, keep the bastards honest. You want to say, I want an independent view of what I want to look at. So a lot of the proof of concept labs that are out there use third-party tools because they want to have an independent view of their setup. So even though they want to sell you a whole kit of whatever, they still want to test it independently and have people understand that, hey, we've tested it with something different. It's not our guys, it's not our product saying that everything's really sweet. And being able to have historical and correlated view is really important. You want to make sure that, am I getting this data, and can I correlate, and can I see that when that event happens, I can see this sort of information. There's a lot of bespoke tools out there that will just tell you got something wrong there, then you've got to switch to this one, you've got to switch to that one. So, which goes into how to best monitor Wi-Fi. So multiple sources is key. Don't take one. Telemetry data for wireless LAN controllers is important. They're the things that are getting information back from your from your APs. SNMP is good. Good to understand what's going on from that perspective. NetFlow, JFlow, SFlow, whatever flow there is these days, that's good too. But packet data is critical. I've come from an area where packets are king. Packets don't lie. Packets will tell you everything. Well, not everything, but they'll give you, especially on the wired side of things, they will tell you when the application's problematic, when the network's problematic, or when you've got TCP problems and things like that. And then the ability to look at these in a correlated view. So take our little network design. We've got TAP and we've got aggregators and we've got a monitoring tool there. So taking packet data outside of the sort of access switch area, understanding wireless LAN controller telemetry, and of course SNMP data. And you sort of mash that together and you should get a good understanding of what's going on. So if you're doing this sort of stuff, then that's a really good start into how to look at sort of the wireless environment. Why? Well, traditionally network tools treat the wireless medium as a black hole. It's like if you've got one of the telcos as being your supplier for networking, you get to your edge router, and then until you get to your other site, everything else is a big black hole. And you sort of say to someone, one of the carriers say, well, you've got a problem in your network. And they say, no, we don't. And you go, well, yeah, when I go here, I have bad performance. And they go, no. And they go, oh, hang on, just try it now. And then suddenly it's miraculously, it's all good. So understanding that black hole, especially around wireless, can be hard with traditional tools. So, but it'd be great to be able to pinpoint an issue to a floor or even to a single IP, because there's a lot of additional issues around wireless environments. Wired environments don't change with length or with range. If it's a 10-meter cable or a 20-meter cable or a 100-meter cable, it's the same throughput. You don't have DFS issues. You don't have noise, well, unless it's really, really bad noise. So there's issues there. So without packet, so this is a real grab. So as you can see, there was like 40% of bad problems. What was it? Oh, I can't quite read that. But it was 40%, I think it was 40% of user errors that were getting problems with Office 365, and they just could not get good application performance. And so it was like, oh, it's the wireless network. That's the first thing. The wireless network, the wireless sucks. When I do it on the wired, it's all good. When I do it on the wireless, it's bad. But as it came down to, you can't see that here, there was actually TCP randomization issue on a firewall. Now, you're not going to get that without packet data. And sometimes you won't see it without finding wireless stuff. So bringing them together gives you a good understanding of what goes on. Again, benchmark your environment. I mean, this is quite a busy graph, but it comes down to how many sticky clients do I have? What's my wireless currently doing? What's the loading on my access points? Do I have DFS enabled? Do I have band steering enabled? All these sort of things. Understand what's going on in your network before you do any upgrades, before you do any migrations. The amount of times I've said to people, that they may be doing a survey, and I said, well, what's your wireless been like before? Oh, no idea. What's it like now? Oh, no idea, but we're just monitoring it now. But there's no plan on to do monitoring before and after migrations. And of course, understanding what sort of poor performance, that's a big outlier. I mean, if it was just down here, is that a big problem? No. I mean, is everything always up here? I mean, if this line was always up the top, that's your normal understanding. So understanding where problems occur and understanding how they relate to what you've seen in the past is also very important. So as you can see, wireless performance here, but some TCP problems. How does it know that? Well, it's taken wired data and it's taking packet data and it's going, it's not the wireless environment, it's the packet stuff that's telling me that there's problems with TCP. And again, into here, Wi-Fi performance is bad, so it's obviously getting some information from wireless LAN controllers, but it's roaming okay. So, you know, there's some issues there. Health and remediation. Why is coverage poor? You know, trying to understand poor coverage is really important. So you want to actually get to understanding. In this scenario, you know, we had 700 hours of problems on a particular AP. So once you drill down to that AP, where do you go from there? Well, you've got to go to this guy. I mean, there's nothing that's going to get you further. You've got to go from monitoring into actually, I now know it's that AP down there. I've now got to survey it. I've got to fault find it, or troubleshoot it. So survey it. DFS events as well. It's good to understand, does DFS affect your network? I mean, we all set it up for it. I mean, it happens differently depending on where your office is located. But in this scenario, you'll see, it's hard to see. Channel 116 has an event there, quite dramatic. But also channel 44 is being affected by DFS. Channel 44 is not actually in the DFS range. Yet, if I go to this graph, which is again hard to see, it's bouncing all over the place. So channel 116 goes to channel 44. Channel 44 goes back to 116, and vice, and on and on and on and on. So why is channel 44 being adapted by problems? So the final bit is just sort of understand the ecosystem. Everyone knows Kenny about trying to put too much stuff down a 1-inch pipe. Understanding your DNS, your DHCP, your authentication, your backhaul. So a lot of complaints come down to Wi-Fi. The Wi-Fi is bad, but I've actually connected, I've authenticated. So sometimes DNS or DHCP is a problem. You know, have you authenticated? Well, you've authenticated well, but do you have exhaustion pool problems? Does your DDI solution help you there? Those sorts of things. Are things correctly sized? You know, are your leases running out? Do you have visibility on your leases? Do you have visibility on your usage? So it's really good to understand those sorts of issues. And again, backhaul. Backhaul is starting to become more important, especially with AC to AX migration, N-base-T. You know, have you tested the backhaul? I mean, a lot of people now are starting to run into problems where they're putting up all these access points, they're getting good coverage, but now, you know, when they start to migrate to AX, or they will start to see when they start migrating to AX, that the backhaul is starting to have some issues. So understand that. You know, if you have to, test it. You know, there's different ways of testing it. You can do iPerf, of course, you know, multiple iPerfs, or you can go and get some tools, or you can call companies out to do it for you. But understanding what it's giving you, benchmark it, know what you've got. That's solves a lot of your problems before you start. And of course, just a couple of things on these sorts of terms. I typically don't like buzzwords. I'd be aware of marketing hype. I've dealt with many, even people we represent say, oh, this is going to give you, you know, root cause. And it's like, no, it's not. It's going to help me get to root cause, but it's not going to give me root cause. So, you know, AI. I don't think we're quite there. It's just machine learning at the moment. Vendors do it very, very well, but at the end of the day, they're using historical analysis. In fact, some of the screenshots I showed you before, they have an AI, they do an ML, machine language type of scenario, but it's really taking, I've seen this happen 400 times before, so now this is what we're seeing. So, you know, the guess is that this is it. And a lot of the time, machine learning is your best guess. 90% confidence level that this is what's going to happen. So at least it gives you some area to start going fault finding. It gives you an area to know where to start. Of course, root cause analysis. There is no magic bullet. If there was a magic bullet, someone would have come out with it and said, I have this thing that will tell you everything you need to know, and you can do it all in one hit. But usually you derive from multiple tools through fault domain isolation. So as before, I showed you, we found an AP that was problematic. You've got to go out there and you actually got to go and find what's going on. And then between the two tools and maybe another tool or maybe a bit of Wireshark or things like that, you get to that root cause. And of course, the last one, which is single pane of glass, which I think if I had a nip of every time I heard someone use that, I'd be drunk probably most of the time. I really hate this. I get people tell me this all the time, that it's a single pane of glass view. It'll give you everything. If it gives you everything, then the screen's going to be massive. And if the screen's massive, it's just going to give you a pane. And so much so, I have a blog which we call Single Pane of Glass because we don't like that. So I've got a couple of seconds to go. Some useful tools that in the market that I see, and when I mean useful tools, I mean they're free or really low cost. On Mac, Wi-Fi Explorer Pro, Wi-Fi Signal. I use both of these on my Mac. There's a lot of guys that do use it. There's a guy by the name of Adrian Granados that does it. I mean, they're pretty low cost. They're really, really useful. This one is essentially useful just for understanding what your current status is. But yeah, very, very nice GUI, especially in the Mac. And it's pretty much replicated into WinFi Lite on Windows by a guy called Hel Keck. He's actually an engineer that works for another vendor. And this is sort of like a side project of his, but he's been spending a lot of time on this. It's a really cool bit of kit that sort of gets you there. And of course, this little guy there, the wireless LAN Pi, I've been using that for a while. It's nice little iPerf 3 server, good for any tool, so it works across the board, doesn't matter. It's got Kismet on board, does some speed tests. It's great for Ekahau throughput tests. In fact, that throughput test I did before, I actually used Sidekick as well, and I got a same answer, so I didn't bother putting that in, but yeah, so it's really cool. So and that's from Wireless LAN Pis. And pretty much there, the screenshots, the people that I brought, where the screenshots came from, and that's it. Thank you.
All right, thanks, Dom. Okay, so we are going to take a quick break.